Let us now find the entropy in an irreversible process. So this is an irreversible process, that is why it is shown in dotted line. And from 2 to 1, it returns to state 1 through a reversible process. And you know that for an irreversible cycle, you know cyclic integral of delta q by t will be less than or equal to 0. So that means you can write integral 1 to 2 delta q by t plus integral 2 to 1 delta q by t reversible will be less than or equal to 0. So note that this is a reversible process and this is not a reversible process. This is an irreversible process. That means integral 1 to 2 delta q by t plus s1 minus s2. For a reversible process, you can write like this, s1 minus s2. So this will be less than or equal to 0. So s2 minus s1 you can write it as it will be greater than or equal to integral 1 to 2 delta q by t. So for the entropy change of an irreversible process, that is equal to s2 minus s1, can be written as this will be greater than delta q by t, that is integral 1 to 2 delta q by t. This is not equal to integral 1 to 2 delta q by t, but it will be always greater than delta q by t, integral 1 to 2 delta q by t. So this is the entropy change in a reversible process. So entropy change in an irreversible process will always be greater than this quantity. So for an irreversible process, entropy change will be high. So this can be written as S2 minus S1 plus integral 1 to 2 delta q by t plus S generate. That is the entropy generation. For an irreversible process, an additional entropy will be generated. This is called S generated entropy.